So we have the given vectors and its own component. For vector A, we have 3i plus 7j minus 6k. Vector B, negative 5i plus 4j plus 3k. C is equal to negative 2i plus 9j plus 9. So for the application part A of the dot product, we're gonna compute the angle between the two vectors. So for number 1, we're going to compute the angle between vectors A and B. So we're gonna use the formula of cosine theta is equal to dot product of A and B over the magnitude of A and B. So yung nasa kabila pero lang yan. So to get the dot product of vector A and B, just multiply the components of it, and now we have the scalar of negative 5. And for the magnitude of vector A and B, just square the components. For vector A, we get 9.6 times. And for the magnitude of vector B, just square it and put it on the calculator. And then we have the magnitude of 7.0711. And now that we have the dot product and the magnitude of A and B, just substitute it on the formula and press it on the calculator. And there we have the angle, which is 94.1824 degrees. Okay, so same process on the angle between vector B and C, which is get the dot product of B and C and then substitute it. And now we get the value of 36.748 degrees. And that's so for the angle between A and C, same process will apply. Cosine theta is equal to dot product of A and C over the magnitude of A and C. So for dot product, we have 3. And for the magnitude of A, we have, just press it on the calculator, 9.6954. And for the magnitude of vector C, we will square the components, put it on the calculator, and then square root the answer, and then press equal. And we will get the magnitude of 12.8841. Now that we have the values, let's put it on the formula, and we will get the angle of 88.6238 degrees. And for the part B application of the dot product, we're going to find orthogonal components of vector A to B and the vice versa of this. So we will use this formula, which is A cosine theta is equal to dot product over the magnitude of the direction, which is B. So we have the dot product negative 5 and the magnitude, which is 7.0711. And insert on the formula, we will get the negative 0.7071. And for the vice versa, which is B cosine theta is equal to dot product of AB over the magnitude of vector A, we will have this negative 0.5157. And for the orthogonal components of vector B to C and the vice versa, we will have the B cosine theta is equal to dot product of B and C over the magnitude of letter C, vector C. Let's substitute 73 over 12.8841 will give you 5.6659. And for the vice versa, C cosine theta is equal to dot product of BC over magnitude of B, we will have 10.3237. And for the orthogonal components of A to C and vice versa, we will just apply the same process above. So we get the dot product and the magnitude, we just substitute it and we will get the value. So from A to C, we have the 0.23.8, and for C to A, 0.3094. And for the last part, getting the cross product, we will use the matrix to get the answer in the fastest way. So for the cross product of vector A and B, recall the value of A, vector B, and vector C. So the cross product of vector A and B, draw a line part, and we are going to put it here the components of A and B from letter I to K. For I, we will do the cross multiplication and then subtract it term by term, components by components. So let's simplify it, and we will now get another vector, which is 45 for I, 21 for j, and 47 for k. Same process on the next two vector, which is the B and C. Use the matrix again. So cross product the components and simplify it. So we get another vector, which is 9i plus 39j, and for the k is negative 37. And for the cross product of A and C, we'll put the value on the line of every component, and we will cross multiplication and the product of it will subtract, and then we will gonna add and subtract or simplify the every term. So we get another vector, which is 117 for I, negative 15 for j, and positive 41 for k.
Let's now proceed to the C++ program for the multiplication of vector quantities. Just like in our first video, we included this one in order to load files, to perform the mathematical operations in our program, to read the C in and C out, and also to start the program with an entry point. So first, we need to declare our variables. So these are the variables that we will use in our entire program. And we use the floating point data type in order to show the decimal values. Next, the components of the vectors. The x, y, z components of each vector. So, the program will ask the user for the x, y, and z components for the vector A to vector C. And in order for us to input the values, we need this in. So, this is the program for the components of vector A, B, C. Next is the magnitude of each vector. So, this is the magnitude for vector A, vector B, then vector C. We just simply use the formula square root of x squared plus y squared plus z squared, the x, y, z component. So, we didn't use the x squared, but simply we use the variable multiplying it by itself, since the program or the C++ is able to solve the squared operator. Next is the dot product of vectors. So this, we included this one, the magnitude of vectors, since it is needed in the formula for the dot product of vectors. So this is the dot product of vectors A and B, then vectors B and C, then vectors A and C. So simply ax times bx plus ay times by plus az times b. And just substitute for bc and ac. So it's just the same, but different components or variables since they are different vectors. So that's it. This is the program for the dot product of vectors. So the application of dot product of vectors is needed for the angle between vectors, also for the orthogonal component. First one is the angle between vectors. So just like what I've said, we use the magnitude of vectors. So we need that, we need to multiply that for the formula in finding the angle between the vectors. So arc cosine dot product of AB over magnitude that is multiplied for this one. So arc cosine dot AB over magnitude of AB. Since the value that we will get here is in radian, we need to convert it into degrees. That's why I included the formula in the conversion of radian to degrees. So the value that we will get here, so this one multiplied by 180 over the value of 5, which is 3.1416 degrees. So included radian to degrees. The same way for the vectors B and C, but just substitute different variable. So this is the program for the angle between vectors B and C. The angle between vectors B and C. So that's it. That's how we will use that, or in order for the program to know the angle between vectors. Formula. Next one is the orthogonal component of the vectors. That's the second application of the dot product. So this one is the formula to know the orthogonal component of the vector. So the orthogonal component of vector A to B is simply this one. Since orthogonal component of vector A to B is simply A cosine theta, that's why we need the dot product of AB over the magnitude of B. Since dot product AB is commutative, that's why I also use the same here, but different magnitude over. So that's it. So that's for the orthogonal component A to B and B to A. Same way with B to C and C to B. Also to A to C and B to A. So this is the formula. So this is the program, the orthogonal component of the vectors. And lastly, the cross product. So you just simply type in the formula that is aligned with the matrix. So this is the cross product of A and B. And this one is the cross product of B and C, cross product of A and C. So those formula will be shown here in the Cout, in the output part. So later on, we will show that we will be able to see that once we compile and run the program, then return here. So let's now run our program. We will just simply input the values based on our given lab. First, 3, 7, 60, negative 5, 4, 3, negative 2, 9, 10. So that's it. You are just going to input the XYZ component. Then the program will automatically solve the dot product application part A is the angle between vectors, the product application part B, which is the orthogonal component of the vectors, and lastly the cross product. So these are the answers for our third laboratory. So that's it. Thank you for listening.